Hey there. Today we're going to learn how to find the combined volume of composite figures. And composite figures or compound figures or complex figures, it basically is just talking about um, a figure that has one or more prisms attached to it. So first example we're going to look at today involves a Lego. So we know with volume, we're looking at a three-dimensional object, and we're looking at how much space is inside of this three-dimensional object. So for this example, we're going to try and find the volume of this object by breaking it apart into rectangular prisms. You can see it's not a rectangular prism at the moment, but we're going to break it apart here in just a second. And then we're going to use our volume formula, which we know as length times width times height, to help us find the combined area, or I'm sorry, the combined volume. So looking at this figure, I can see that it's actually made up of three different rectangular prisms. So if I break this apart, I want to try and find the volume for each prism individually. So if we looked at just one of these pegs as one cubic unit, we can find the length, the width, and the height for each one of these objects. So let's start with the first one. The first one will say it has a length of 2 units. It also has a width of 2 units. And we'll say that the height is simply 1 unit. We'll say that it only goes up 1. If we look at the second rectangular prism, we see that it has a length of 3 units. It has a width of 2 units as well. And again, the height is going to be the same as just 1 unit. And then finally, with our last prism, we have a length of 4 units. Our width would be 2 units, and our height is still going to be 1 unit. Now, again, I can find the volume of each one of these individually by multiplying the length, the width, and the height together for each one. So let's go ahead and do that. 2 times 2 is 4, times 1 is also 4, so the volume for this first prism is equal to 4. For the second one, 3 times 2 is 6, times 1 is still 6, so the volume for the second prism would be 6. And for the last one, 4 times 2 is 8, times 1 is 8, so the volume for the third prism would be 8 units. Now, we said it's a combined volume, so we're not going to want to multiply these volumes together once we find them. We're going to want to actually add them together to find my total volume of the compound figure. So if I added all of these back together, I'd really be taking the volume of this plus the volume of that plus the volume of the bottom one, which would give me 4 plus 6 is 10, plus 8 is 18 units cubed. Since there wasn't any units given to us here, there weren't feet or inches or centimeters, we would just say that the volume, the total volume, is 18 units cubed. Let's take a look at another example. In this example, we'll use a example from our book. Again, we see a compound figure or a complex or composite figure. It just means that there's more than one prism in this example, and this can be broken apart into 2 prisms. So we could say that this is the prism 1, and we could say this is prism 2. And in order to find the volume of each, we need to identify the length, the width, and the height of each one of these. Let's start with the bottom, with number 2. So we'll say this is prism 1 and prism 2. So starting with prism 2, all you need to do to find the length, the width, and the height is find one point where all three lines come together. And there are several of them. I'm going to choose this one right here. And I notice that I have 1, 2, 3 lines that all meet at that point. And those 3 lines are the length, the width, and the height. It doesn't really matter which one is which, as long as you can identify all 3. So we would say if this was the width, we would say that the width for prism 2 is equal to 6 meters. If this is the length right here, we could say that the length is equal to 8 meters. And if this is the height right here, we can say that the height is equal to 5 meters. Okay, take a look at our top prism that we have, prism number 1. If I, again, just choose any point where 3 lines meet, I could choose that one. I see here that the width is not given to me. I only see the length and the height that's listed here. So let's go ahead and identify the length is equal to 3 meters. The height is equal to 5 meters, but the width, it doesn't have a third length up here, or a third measurement up here. So using what I know about prisms, I'm going to look at this and I'm going to say that this line right here is equal to this line, and this line you can see is the same length as this line, which would be equal to this line down here. So we can actually see that the width for my first and my second prism is equal to 6. This is all the same on all of them. Okay, now to find the volume, I'm going to multiply these 3 numbers together and come up with a volume. So 6 times 3 is 18, times 5 would give me, 8 times 5 is 40, 5 times 1 is 5, plus 4 is 90. We would say that the volume of prism 1 is 90 meters cubed, or 90 cubic meters. For prism 2, we're going to do the same thing. We're going to multiply. 6 times 8 is 48, and then times 5. 5 times 8 is 40. 5 times 4 is 20, plus 4 is 24. So we would say that the volume for prism 2 is 240 meters cubed. Now again, in order to find the combined volume of both of these, I need to simply add those two together. So 240 plus 90 would give me a total of 330 meters cubed. So my total volume would be equal to 330 cubic meters. Let's try one more example. In this example, we see a similar figure. Again, I'm going to go ahead and identify this as volume, or this as prism 1, and this is prism 2. And as I start collecting my lengths over here, I'll say that this is for prism 1, and this is for prism 2. Okay, we'll start with prism 1. And again, if I pinpoint any point where 3 lines come together, I see this length right here, we could say is my height, is equal to 3 inches. This line right here, we could say is my length, and that's equal to 7 inches. But this line right here, we don't see a measurement for listed up here. So what do I need to do again is recognize that this line and this line are equal. And this line have to be equal. And that line and this line would also need to be equal. So we can see that up here is the same as 4 inches. Now let's find the volume of find the dimensions of my bottom prism. Again, I'm going to identify one point. I can already see that the width for this one is going to be the same as 4 inches. We can say that the height right here is going to be equal to 6 inches. And we can see that the length, this number right here, is equal to 15 inches. And now again, in order to find the combined volume, I'm going to want to multiply the length, the width, and the height for each one separately. So let's start with this one. 3 times 7 is 21. 21 times 4 would give me 84 inches cubed. For this prism over here, 6 times 4, let's multiply these two together to give me 24. And then 24 times my leftover length is 15. So 24 times 15, 5 times 4 is 20. 5 times 2 is 10 plus 2 is 12. Bring my 0 placeholder, 1 times 4 is 4, and 1 times 2 is 2. When I add those together, I come up with 360 cubic inches. Now again, in order to find the total volume, I need to add these two numbers together. So 84 plus 360, 4 plus 0, 8 plus 6, and 1 plus 3. I come up with a total area, or total volume of 444 cubic inches.